Okay, guys, so what we're going to do today is we're going to work on absolute value inequalities. Now, this is connected to what we call a compound inequality. So let's review those for just a bit. Okay, a compound inequality is connected by two different words. And the word or. Okay, so let's take a look at the graphs and how we could write either of these. Okay, so if we have an or statement, x is less than -5, or x is greater than 2, okay, we'll actually see the word or. Okay, so let's put that on a number line. So I'm just going to put -5 here, +2 here. They both get open dots. Okay, less than 5, greater than 2. Okay, so we have a couple different ways we can write these. Okay, so this is what we call inequality notation. Then we have graphical notation. And then we have something called interval notation. Okay, so we have to remember that negative infinity is on our left. Go to -5, and then 2 to positive infinity on our right. Now, there is a weird little symbol that goes in the middle. Looks like this. Okay. That is the union symbol. Okay, so look for that when you're doing notes and stuff. Okay, so a simple example of an and statement. Okay. Now, and statements look like this, typically. We'll just use the same numbers. I'm going to switch around the inequalities. Okay, so that would be inequality notation. Now, notice that x is between the -5 and the 2. Okay. So you go -5 here, 2 here, closed dot for our -5, open dot for our 2, and we want x between, like this. Okay, so that would be our inequality notation. Our graph. And then finally, we could write this. We can actually write it two ways. So probably the most common way would be this. That would be our interval notation. Okay, but, okay, just so you are aware, a less common way to write it would be this. Okay, that's a really weird way to write it. It's not common. It's still correct, though. This little symbol right here is the intersection. Okay, so it means what's common to both of these sets, which is just the middle ground where x is between -5 and +2. Okay, now what we're going to do is we're going to extend these guys to our absolute values. Okay, so instead of solving absolute value equations, we're going to solve absolute value inequalities. Okay, so I'm going to show you a couple different ways to do this. Okay. All right. Let's start off with this one. Okay. All right. So first thing you want to do is you want to make sure that your absolute value expression of x minus 5 is isolated. So we're going to go ahead and divide by 2. So we have absolute value of x minus 5 is less than 5. Okay, so first we're going to do algebra. Okay, so we have to take into account both cases. Okay, so the positive case, nothing changes, everything stays the same. But when we do the negative case, since we're going from the opposite direction, we have to change the direction of our inequality. Like that. Okay? All right, so here we go. Let's solve. Like, whoops. Okay, now if we graph these on our number line, okay, open dot goes this way. Open dot goes this way. Notice that these come together. Okay, so this tells me that this is an and statement. So my graph would look like this, and my interval notation would look like this. Okay, let's do another one algebraically, see what happens. Okay, here we go. Let's do something a little bit tougher. Okay, so first thing you want to do is you want to make sure, okay, that your absolute value expression is all by itself. So we're going to go ahead and subtract our 10. Now, when you divide by a negative, remember you have to switch an inequality symbol. So when we divide by this negative 3, we get that. Okay, so again, positive and negative case. Negative case. Remember to switch your inequality. Positive case, everything stays the same. Solving by subtracting your 5. And let's graph. Okay, so there's negative 6. Close dot goes this way. Negative 4. Close dot goes this way. Again, this is another and statement, so I can write my answer in inequality notation like this. Okay? All right, let's do one more. Great thing about videos is you can press pause. All right, let's do one more. Okay. All right, let's see what happens. Okay, again, we're going to do some algebra. First, we're going to add our 10. And we're going to get 15. Then we have to divide by 2. Okay, so your choice on whether you use 15 over 2 or 7.5, completely up to you. Okay, so now you are ready to do the positive and negative case. So, negative case, remember to switch your inequality. Like that. All right, so we got a fraction to deal with. Now you do have an option here. You can clear the fraction. Okay, so if you multiply everything by a 2, okay, you're not going to change the inequality symbol because it's a positive 2, but you are going to clear that fraction out. So let's do that. Okay, I'm still going to get a fractional answer, but instead of having in the middle, it's going to happen at the end. Okay, so that makes it a little bit easier. So we're going to add our 10 to both sides. And we're going to divide by 6. Okay, again, we still get our fractional answer, but since we cleared up that 2 at the beginning, makes it a little bit easier. Okay, here we go. Let's graph. Okay, so negative 5, 6 is going to be on the left-hand side of 0. And 25 over 6 will be on the right-hand side of 0. Okay, close dot to the left because it's less than. Close dot to the right because it's greater than. Okay, so this tells me I'm dealing with an or statement. So when I write it in interval notation, I will get that. Okay, all right, so we're going to stop right there. Okay, and then in the next video, I'm going to show you how to solve them by graphing on an XY axis, not just the number line. Okay, so we will keep that to the next video.